Hi everyone, in this video I want to show you how to take the second derivative of this function, square root of x squared plus 1. This calculation is very important and requires all kinds of derivative techniques, so it's a good problem. Well, first step is to rewrite this radical function into an exponential form. It's a square root, so you can use the power of 1/2, right? So now this is a composite function. You can decompose this composite function by introducing the intermediary variable u. What's inside the parenthesis is now u, so u to the power of 1/2, where u is x squared plus 1. This function is the same thing as this. Okay, to find the second order derivative, you need to take the first derivative first. Okay, so y prime. So how do you take the first order derivative of this composite function? Well, if you remember, it's dy du times du dx, right? That's the chain rule. So looking at the mother function, yeah, y is now a function of u, so you take the derivative of y with respect to u, 1/2 pops out, and then u, the exponent writing on u is now decreased by 1, so you take away 1 from 1/2 times, that's this part, then the second part is the derivative of the child function, u equals x squared plus 1. So you're looking at this function and take the derivative with respect to x, right? So which is just 2x. Right? Well, then you find that these two cancel out, and this becomes negative 1/2. Therefore, the first order derivative of y becomes x squared plus 1 to the power of negative 1/2 times x. Well, this can be written using the radical form as x over square root of x squared plus 1. Well, you don't have to write in this way, because you got to take the second derivative, another derivative on this function, and right, so you need to bring this function to this form anyways. Alright, the second order derivative is more complex, because your first order, you're going to take the derivative on the first order derivative. So d over dx on the y prime, right? It's the second order derivative, which is I'm going to change the size of x and this for convenience. It's the same thing. A times b equals b times a, so just swap them over. Now the reason why I did that is because I want to apply the product rule here. Two different functions are multiplied, right? And then it's taken for the derivative, right? So if you remember the product rule, u times v, where u and v are a function of x, it becomes u prime v plus u v prime, right? Something like that. So this is your u and that's your v. So you take the derivative of x, so that's just 1, and then the second function is untouched. Okay, and then next is the second. The second term is the opposite. The first function is untouched, so x is carried over, and the second term is the derivative of this function. Again, it's a composite function, right? So that's more difficult. The power riding on x squared plus 1, the child function, is now negative 1/2. So that comes out when taking the derivative of this. Negative 1/2 comes out. And then the power riding on the parentheses is now decreased again by 1, right? And then you don't want to forget, multiplying by the derivative of the child function. The chain rule is applied here again. I don't introduce u here because it's the same business as before. Okay, so what I'm doing is I'm taking the derivative of this function. Okay, so the child dx is 2x. Right, so it looks quite messy, but let's clean up the mess. The first term is okay. This one is very simple because the numerator is just 1 and the denominator is square root of x squared plus 1. Yeah, this parenthesis is submerged in down to the denominator. The second term is kind of messy here, right? But oops, I gotta change the sign to negative because there's a negative sign sitting here. This 2 and that 2 cancel out. These two x's are multiplied together, so x2 is sitting in the numerator, and when looking at the power acting on the parentheses, it's negative 3 over 2 now. Negative 3 over 2. What does that mean? It means that what's inside the square root is now cubed. So x squared plus 1 cubed is happening here. Right. It looks like this is the end. Yeah, you could stop here, but we can go ahead and simplify further by coming up with the common denominator. The common denominator of this and that is this, because this has more square roots, right? So in order to make the square root of x squared plus 1 cubed from the first fraction, you need to multiply both sides of the fraction by x squared plus 1. Does that make sense? Because x squared plus 1 to the first power is now x squared plus 1 cubed. That's inside square root, right? So I want you to figure out this calculation. It's the power rule, the exponential rules. Now we have the same denominators, so we can combine these two fractions. what's great about this is that x squared goes away. Right? So it makes the result quite simple. So this is the final result.